Right, welcome back students to one more session of your salt analysis. That is, we have started with the qualitative analysis of your grade 11 and grade 12 chemistry. Now in salt analysis, I've already taught you, let me recollect what I've taught you. I've done videos on preliminary tests. So preliminary tests are already done. After this, I've taught you identification of group 1 acidic radicals, right? So that now in this particular session, I'll be introducing or teaching you what are group 2 acidic radicals. I'll be teaching you their identification. I'll also be teaching you the confirmatory test for them, how to do in the lab, right? So when I have to go with the class 2 acidic radicals, okay, class 2 acidic radicals, right? So most important thing in class 2 acidic radicals, when you take the test tube, when you add concentrated sulfuric acid or when you add concentrated HCl to this, either there is evolution, oh you have your salt here, either there is evolution of gas or certain amount of effervescence, or we'll see what are the different vapors which are observed in that. So the gas or the salt or the anions which respond to this are halides, that is chlorite. The anion which responds to this is bromide. The anion which responds to this is iodide. The anion which responds to this is nitrate, NO3. The anion which responds to this is oxalate. Right, so all these ions, let us write the full forms of this, because when you write your result or report, you need to write the given salt contains the acidic radical ion formula, and you write the full form also, right? So that's why I'm writing this: bromide, iodide, nitrate, oxalate. Now let's come back and start off with the first one, that is chloride. How to test chloride in the lab? What is the confirmatory test? That is Chromyl Chloride Test. For bromine, layer test. For iodide, starch iodide test or starch paper test. For nitrate, we'll be doing brown ring test. For oxalate, I'll be showing you how to test oxalate. Even there is a project in grade 12 testing oxalate in guava fruit. Let's start off. Right, so welcome back students. Let us start off with the group 2 acidic radicals. Now what should we remember? First, we have ruled out group 1 acidic radicals. If they are not responding to dilute sulfuric acid, you will just switch over to group 2 acidic radicals. So what you're going to do, you're going to take your test tube, add in a pinch of salt into that and start adding concentrated sulfuric acid or concentrated HCl. Suppose if you observe any or if there is a release of any gas or vapor from that, you will immediately start off or assume that group 2 acidic radicals are there in that and start off with the confirmatory test. So let me start with the first acidic radical of group 2, that is chloride. Suppose if the given salt is chloride, if chloride is present in that, your viva question, what is the name of, or the examiner may ask you, what is the colorless gas with pungent smell which evolves when you are performing the Chromyl Chloride Test, or if when you are performing the confirmatory test. So remember, suppose if you have a chloride anion in your salt, the pungent gas or the colorless gas with pungent smell is HCl. Let us come back and see where is this HCl released. First, what you're going to do, as I said, once you get confirmation from the concentrated HCl, you're going to take the salt. In this case, the salt which I have taken is sodium chloride. It can be barium chloride, zinc chloride, magnesium chloride, any of the combination which is given by your teacher. So now I have taken sodium chloride salt. As I said, I need to test it with concentrated sulfuric acid. So observe, when you are adding concentrated sulfuric acid into your salt which is given to you, immediately from the test tube, colorless gas with pungent smell comes out as soon as you add concentrated sulfuric acid. That colorless gas which is observed when chloride anion is present is hydrochloric. So hydrochloric acid we speak, but here it is in the form of gaseous state. So immediately what do? You take the test tube, now you started observing colorless gas with pungent smell. Now you're going to take in one more test tube, or the same thing also you can add, not a problem. You're going to take ammonium hydroxide and drop it into the test tube which has, where you're finding HCl, evolution of HCl. Immediately you will observe dense white fumes, immense dense white fumes are observed. So this dense white fumes are due to ammonium chloride. One more question. What are the dense white fumes observed when HCl is added to ammonium hydroxide? So ammonium chloride. Because of this ammonium chloride, dense white fumes start evolving, and this gives us the observation that chloride anion is present. So hope it is clear. Let us do the confirmatory, then recollect what we have done. So now I've got dense white fumes. I'll discard that, then start off fresh. Now I'm going to the confirmatory test of chloride. The confirmatory test of chloride, and the most common and very important and easy way to analyze chloride is Chromyl Chloride Test. So in Chromyl Chloride Test, let us see the procedure first and go to the reactions. What should you do? In Chromyl Chloride Test, what do we require? I basically require, important thing, salt already given to you, test tubes also done. I require potassium dichromate, which is an oxidizing agent there. I also require concentrated sulfuric acid, as well as I require sodium hydroxide. First, what you're going to do, you're going to take a test tube. You're going to add salt into the test tube. After that, you are going to add potassium dichromate to the test tube 1, which has salt. In one more test tube, you're going to keep sodium hydroxide ready. Okay, now this sodium hydroxide is here. Now we have salt with potassium dichromate as well as salt. In the last step, you're going to add concentrated sulfuric acid to the test tube containing potassium dichromate. Let us come back and draw what we have thought of. So I said, in the first test tube, you're going to take salt. To this salt, you're going to add K2Cr2O7. In the second test tube, you are going to take and keep ready sodium hydroxide. After you keep, the final step, you're going to add the corrosive acid, that is concentrated sulfuric acid. So here goes in concentrated sulfuric acid. Now this is ready, isn't it? Now observe. Your salt, potassium dichromate, concentrated sulfuric acid. Your salt, concentrated sulfuric acid, potassium dichromate is done. So when you add all these, so you're keeping this regular. Now see here. You're going to take this and transfer the sodium hydroxide into this test tube. When you hold it and transfer it into this, what happens is, observe carefully, salt plus sulfuric acid forms a sodium bisulfate. And in the process, in the same test tube, potassium dichromate and sulfuric acid is there, isn't it? So this potassium dichromate, which is an oxidizing agent, gets converted into CrO3 in the test tube, in the first test tube. Once that is done, when you are adding your sodium hydroxide to this, right? So immediately, just observe the CrO3, the potassium chromate, which is there in this test tube, and the addition of concentrated HCl also, right? Concentrated HCl, it gets converted. It means concentrated HCl is your, this one. If you take as a salt here NaCl is a salt, here HCl is this one. So when you add this, it's going to form reddish vapors of chromyl chloride. As soon as you mix these two, it's going to form reddish vapors, that is called reddish brown vapors of chromyl chloride. Simple reaction till here, just see, done. This reddish vapor, chromyl chloride vapors, as I told you, it's going to, once you take this reddish vapors, and I told you, isn't it? Now this particular test, you have got the chromyl chloride. Now once this chromyl chloride is transferred into, or sodium hydroxide is transferred into chromyl chloride, it's going to form not the PPT, an yellow color solution of sodium chromate. Not PPT, it is an yellow color solution only. Just you get the change from reddish brown, it's going to turn into yellow color solution. Hope this is clear. This part is the first part, this part is the second part. Now you're going to take this yellow color solution and add lead acetate to this. So chromyl chloride is formed, then I added into sodium hydroxide, yellow color solution is formed. From the yellow color solution, now I'm going to add lead acetate to this. When you add lead acetate, a yellow color precipitate is formed. Remember, the last step is yellow color precipitate. So this yellow color PPT is lead chromate. So I have 3 different Viva questions in this. Question number 1, what is the gas evolved? Question number 2, what is a reddish brown vapor? What is that? What is the name of that? Chromyl chloride. Question number 3, what is the yellow color PPT formed when you confirm chloride? That is, you will say lead chromate, right? So students, once again, let us recollect chloride test. Let us understand once again. So first, I tested with taken the salt, I have added concentrated sulfuric acid. I observed HCl vapors which were colorless gas with pungent smell. After that, I have taken ammonium hydroxide, added to that. I started observing dense white fumes, chloride observation to, if I have to say, 50% done. Now I am going to perform the chromyl chloride test. I will be taking 2 test tubes. In the first test tube, I will be adding salt, potassium dichromate, potassium dichromate and concentrated sulfuric acid. During this process of this, you will be getting conversion of dichromate into chromate. Once that is over, next step, as I told you, here we have taken HCl again, means the salt which is taken, it's going to form reddish brown vapors of chromyl chloride. That is happening, that's over, this step. Now once you add sodium hydroxide to this chromyl chloride, you will be getting an yellow colored solution in that. Don't write PPT, wrong. Yellow colored solution is due to the formation of sodium chromate. To this sodium chromate, I will be adding lead acetate. Correct? Now this will give you an yellow PPT. That's because yellow color PPT due to the formation of lead chromate in the test tube. So the yellow color PPT confirms the presence of chloride anion. Right. So after the analysis of the chloride anion, let's come back and do how to test for bromide anion. Right. So these all acidic radicals are going to respond with concentrated sulfuric acid. But remember one thing, whenever you're doing group 2 acidic radicals, so you have to first test with dilute sulfuric acid, rule out there is no gas, then only go with concentrated sulfuric acid. Remember that. Right. Suppose in the given that particular examination day, you're given with a bromide salt. How to see? Just let us start off. So suppose the salt which is given to me has a bromide anion. This is a salt. As I told you, take a pinch of salt in the test tube. You're going to first add in dilute sulfuric acid. So the first step is testing with dilute sulfuric acid. We very well know if there are group 1 acidic radicals, when you add dilute sulfuric acid, either there is observation or you see some effervescence from the test tube or you see some evolution of gas. So when you add dilute sulfuric acid to the group 2 acidic radicals, nothing. See here, there is no evolution of any gas here. So you can rule out, that means you can just get confirmation that carbonate, sulfide, nitrite and acetate are absent because there is no evolution of any gas. Now what you do is you're going to take your salt. Now here HBr, NaBr, HBr, zinc bromide, anything, not a problem. So when you test with concentrated sulfuric acid for the second time, you observe there is evolution of, just see here, HBr plus sulfuric acid, there is evolution of brown colored gas which comes out from the test tube. Bromine is a covalent compound. Remember, a brown color, evolution of brown colored gas when you add concentrated sulfuric acid to your salt confirms or it gives you an analysis that bromide anion is present. So along with that, water and sulfur dioxide. Now important viva question. Your examiner may ask you, he will go and report for bromide anion. Then he or she may ask you, what is the brown color gas which evolves when you add concentrated sulfuric acid to the salt. So don't get confused between the reddish brown vapors and this brown colored gas. Okay, right. So this brown colored gas is because of the evolution of bromine gas. Now let's come back and start with the layer test of bromide. So this layer test of bromide, little bit, keep noting because there's no place here. I'll be explaining, keep noting in your book. Right. Now let's come back and see the confirmatory test of bromide. So the important confirmatory test for bromide is layer test. Let's see what to do. First, for the layer test, step 1, what you're going to do is you're going to take your test tube. To the test tube, you're going to dry the test tube and first add the salt which is given to you. Okay, you're going to add a pinch of salt. Just see the procedure. After you add the salt, now you're going to add to this test tube organic solvent. Okay, so now what is an organic solvent? Organic solvent can be this in chloroform. Organic solvent can be carbon disulfide. Organic solvent can be carbon tetrachloride. Now once you add to this, you're going to get two layers in the test tube. The first layer, the bottom layer, is a heavier, the denser layer of organic solvent. So the bottom layer will be the denser layer of organic solvent. On the surface, you will be having one more layer. That a layer contains your bromide anion. That will be floating on the surface. Now, once this is over, this is a step 1. After this, the step 2, let us see what you're going to do once this is formed. Step 2, you're going to prepare chlorine water in the lab. How to prepare chlorine water? Let's see. So, in the step 2, you're going to take KMnO4 to this. Then, you're going to add concentrated HCl to this. So, when you do add both of these, you're going to get chlorine water. KMnO4 is an oxidizing agent. It converts HCl into chlorine water. Now our chlorine water is ready. Now what you are going to do, you are going to take the test tube which has two layers, and this is your step 3. You are going to take this test tube which has two layers. One is the organic solvent, that is carbon tetrachloride, and the top layer which has bromide. Now you are going to add chlorine water to this. Now already carbon tetrachloride has a lot of chlorine. When you are adding chlorine water, this will become excess of carbon tetrachloride to that. Just see here, salt plus chlorine water, which I have got from by converting concentrated HCl to Cl2. So that one is there. Already I have dissolved in the organic solvent. So when you do this, what happens is, it's going to form, I said, it's going to form a separate layer down. Now this carbon tetrachloride, which has excess of chlorine water, it will convert the bromine anion into Br2. Now this is ionic compound, ionic in nature. Now when you may add more and more, and when you shake it, when you start shaking it vigorously, this whole of bromide, whatever is there, it comes down and it settles down at the base of the test tube here as Br2. So, and the top layer, whatever is there, will become transparent. Now, this particular Br2 is your brown colored layer which settles down at the base of the test tube. So, this Br2, what is this color? It is a brown colored layer. So, this the formation of brown colored layer at the base of the test tube after adding chlorine water, after adding organic solvent, is the confirmatory test for, or it is called the layer test. What is this? The conversion of Br minus to Br2. By which one is converting? The organic solvent is converting that Br minus to a covalent compound. We very well know bromine is a covalent compound. Covalent compounds are soluble in which solvent? They are soluble in organic solvents. So it confirms that bromine is present in the given salt. Let us recollect once again. Suppose if you are getting a confirmatory test, or if you are observing the formation of brown gas from your test tube when you add concentrated sulfuric acid, right? So you can just start off with that. First step is, you're going to take the test tube, you're going to add salt to this, and you're going to test with dilute sulfuric acid. In the dilute sulfuric acid, if no gas evolves, you can discard the test tube and get a confirmation. Carbonate, sulfide, nitrite and acetate are absent. Then you're going to test your salt with concentrated sulfuric acid. On adding, if you get brown colored gas, that confirm, or it will give you an observation that bromide may be present. Then you start with the layer test. As I told you, layer test, first you're going to take the salt, then you're going to add to that salt organic solvent. That can be, as I told you, it can be CCl4, it can be chloroform, or it can be carbon disulfide. Once you dissolve everything into this, you will be getting two layers. That is the reason we'll be starting off with the layer of two layers. So as you've seen, the bottom layer is for which one? It is for the organic solvent, because it is denser. And the above layer, whatever is there, it contains bromide anion. Done. Now you will go to the step 2. You start preparing your chlorine water. As I told you, you will use an oxidizing agent. Then with that oxidizing agent, you will be converting concentrated HCl into Cl2. You will take that chlorine water and add it into this test tube. Once you add, again you get two separate layers. The bottom layer will be more of the organic solvent and the upper layer will be of Br minus. Now what you do, you shake the test tube vigorously. Finally, the whole Br minus gets converted into Br2. So it settles at the bottom of the, or it dissolves at the bottom of the organic layer. We very well know the covalent compounds. As I told you, again I'm repeating, covalent compounds are soluble in which one? They're soluble in organic solvents. So immediately your Br minus gets converted to Br2. So this gives the confirmation that there is presence of bromide anion in the given salt.